Well, thanks everyone for taking the time today. So we're not going to be doing PowerPoint slides. We're actually going to be doing a live demo within the platform and going through a workflow in there. So just at a high level, we're going to be using machine learning to look at optimal Pud value for an operator. So essentially, this is what we have set up. I have a pre-built dashboard that we're going to be going through. You could say I have these 18 steps typed out. I'm basically just going to be stepping through these, just talk through them as we go here. So just to start off, I'll just show you guys the well set that we're starting with. So I'm just going to open our filters here. And so essentially we're looking at horizontal producing wells from 2016 to 2019 in the Midland Basin. And then I've just gone ahead and filtered the most active operators over that time period. So any operator that's drilled over 200 wells over that 4-year time period is what we're looking at. So that's our filter set that we're starting off with here. Now you can see we have the map of the Midland here. We have the wells on there. Right now it's pretty busy. We have a lot of wells and a lot of laterals on there, but we have the wells colored by ticker and the laterals colored by interval. We'll come back and take a look at that once we go through and start filtering down some of the well sets and take another look at that. But that's just what we have set up there for now. Okay, so jumping into it. So there's some pretty basic row charts that we're looking at here. These are probably pretty hard to see, so I'll talk through them here. So essentially, all these 4 row charts are just looking at completion count numbers, and they're just binned by different categories. So this first one here, we're simply looking at completion records or well counts by ticker. So you can see a Pioneer, for example, has 1,000 wells in this 4-year period that we're looking at, and that's just how that's sorted there. We have the same data looking at well counts, but now we're looking at it by subplay. So you can see we have pretty much 95% of the wells drilled within the core of the play. So that's going to be the Midland Central and the Midland Eastern flank here. So you can see those are the 2 biggest bars, and that's pretty much where the drilling's been over that 4-year time period. Very little drilling towards the edge of the play or the non-core areas. This next one is looking at completion counts by interval. So this is looking at what zones have been most actively drilled over that 4-year time period. So we have the Wolfcamp A, the Lower Sprayberry, and then the Wolfcamp B, upper and lower, and then also the Middle Sprayberry here are the top 5 most active zones. And the Middle Sprayberry is very marginally in that top 5 there. And then we're looking at, again, well counts, but this time by vintage. So we're just seeing how many wells are drilled by year. So you can see by far, most wells were drilled in the last 2 years in 2018 and 2019 compared to 2016 and 2017. So just a quick glimpse at that. All right, so getting into some more meaty data. So we're looking at some scatter plots here. What I'm going to do is I'm going to make these full screen so they're probably a little easier to see. Now, what we have the dots colored by is interval, so it's pretty busy to look at right now. Again, we haven't really done any filtering. What we're really trying to look at is the values represented on the y-axis here. So the data we're looking at here, on the x-axis, we have all the operators, so tickers on the x-axis. And on the y-axis, we're looking at lateral normalized EUR per 1,000 feet on an MBOE basis, so oil and gas EUR combined. So basically what this is doing is it's just ranking the operators in terms of their raw EUR performance. We're not normalizing for anything in terms of geo, although most of the drilling's been done within the core, and we're not really normalizing for spacing or anything of that sort, just strictly looking at how are these operators performing against each other just on a total well basis. So you can see we have the top operators here. So we have Chevron, Pioneer, Apache as the top 3 there, right around 100 MBOE per 1,000 foot. And then we can see we have some of the poorer performing operators. So when we're going through looking at optimizing workflows, you typically want to look for an operator that's really underperforming. So that's what we're going to try and identify as we go through these here. So really focusing on these underperforming operators here. So for example, we have QEP, surge operating, and then we have other. This is going to be a basket of private operators who have all been looped into that other ticker there. Now you can see QEP and surge and these guys, they're right around 60 MBOE per 1,000 foot. So call it really far underperforming the top 3 operators. Now we'll jump into this next one here. So this chart here is going to use the completion sensitizer. So I'm quickly just going to go over what the completion sensitizer is and then how we're going to be using it in some of these charts to pull out some analysis. So this is just loading up here. So what we're looking at here is our completion sensitizer page. So essentially what the completion sensitizer is we have XGBoost models trained on all the lower 48 plays. And so what we do is we take all those wells, we run them through the XGBoost, and then we get these pickle files or files that we can use to predict on the output. And so essentially what that allows us to do is a what-if analysis on all the existing wells. So you can see over here, I have a number of completion designs predicted, so these sensitizer scenarios. And so what these represent, for example, for highlighting this 2500/60, that's going to be your completion intensity. So that's going to represent 2,500 pounds per foot and 60 barrels per foot. So that's where the what if comes in. We're basically taking all these wells that we have as existing and running them through these different completion designs by changing that proppant intensity number and fluid intensity number. And then we can see what that EUR performance would look like. So if I just make this full screen really quick, basically we have the basket of every single well run at each one of these completion designs in each one of these buckets. So you can basically see as we increase this completion intensity from, call it 1,000 pounds per foot, 20 barrels per foot, all the way up to 2,500 pounds per foot and 74 barrels per foot, you can see that increase in EUR over that completion intensity increase. And essentially we'll run every single one of these completion designs for every single one of these wells, as you can see here. So jumping back to the main dashboard, that allows us to spin up some pretty interesting charts. Just let this load up, and I'm going to scroll back down to this scatter plot that we were looking at here. So again, we're looking at the colors based on interval. Again, it's pretty noisy. We haven't filtered down to anything. But now on the y-axis, we're looking at % of max oil EUR captured. So since we've done that completion what-if analysis on every single one of these wells, we can take the completion design that maximized oil EUR or whatever design did maximize that oil EUR and what that value is to say like that is the optimal oil EUR they could have captured on these wells. And then we can look at what they actually did. And so that's what this percentage represents. So for example, looking at Endeavor, they did 84% of optimal in terms of looking at their existing wells in terms of oil EUR. So pretty good. And you can see a lot of the operators here are right around that 70 mark. So call it north of 70. And then as we get down to other and QEP, you can see QEP is actually quite underperforming. They're about 62% compared to a lot of their peers, north of 70% there in terms of optimal. Now we can do the same analysis, but this chart here is going to be looking at MPV. So I'll just make this full screen just so we can see a little easier. Now again, we have the dots colored by interval, but now we're looking at what was that optimal MPV or the max value they could have got for these wells versus what they actually did. And it's simply just subtracting the actual from the max. So how much money was left on the table per well in this case. So you can see since QEP was far underperforming in terms of their optimal EUR, they're actually quite a bit underperforming on an MPV basis, to no surprise as well. So on average, they're leaving about 3.5 million on the table as the wells they've drilled previously. All the other operators, they're call it sub 3, low 2 millions. And again, you can see Endeavor, which was performing the most optimally in terms of oil EUR, they're about 1.3 million, so quite a bit lower. So we've definitely identified QEP as being a pretty big underperformer, especially compared to the peers over this time period. So what we can do next is maybe dive into why that may be happening. So I'm just going to click over from the main dashboard into this completions and spacing analysis tab. And we can look at perhaps why QEP is underperforming compared to the peers. So we have two row charts here. So these row charts, basically the way you want to read them, let me just make it full screen here so it's easier to see. Now, since we've run every single completion design for every single well, what we're looking at here is which completion design maximized oil EUR for each individual well. And so what this is saying is, looking at this top bar, which is the majority leader, we have the completion design, which is 2,500 pounds per foot, 74 barrels per foot, and there were 3,100 wells that had their oil EUR maximized using this scenario. So it's basically saying this was the majority winner for maximizing oil scenario for all the wells that we're looking at. We also have the zero case here, which is interesting. So what this represents is how the operators originally completed their wells. That turned out to be the optimal case according to our modeling. So for example, if they completed it maybe with 2,500 pounds per foot and 80 barrels per foot, it would be bucketed into here, as that would have been better than this completion design. For example, this is a collection of completion designs. It's not a distinct design. Just saying how it was originally completed was the optimal way. So that was in terms of maximizing oil EUR. Now what we can do is roll in economics as well as well costs and look at what maximized MPV. And something to note when we're looking at these MPV metrics that we have within the platform as well, it's all done at $55 WTI and $3 Henry Hub. So that's what we've used to calculate these MPV metrics. And once we get further into the analysis, we can explore how to change that as well and see how the answer changes. So now looking at what maximizes MPV, it's still that 2,574 case, but by a smaller majority once we layer in costs. So that's something to keep in mind. That's pretty much the completion design to benchmark against when we're going through this analysis here. So now we're looking at the exact same chart that we looked at on the main dashboard page, looking at percent of max oil EUR captured on the y-axis, but now I've just simply ordered the x-axis by alphabetical. So what that allows us to do is just follow, I'm just going to highlight QEP here, allows us to easily follow QEP or any operator for that matter, just vertically straight down as we go through these charts, since the x-axes are all the same. And something to note on this page as well, we have all the charts again colored by RS interval. So that's just something to keep in mind. So again, we can see QEP, 62%, largely underperforming. Why is that? The first thing we can look at is proppant intensity here. So you can see on average, these numbers are probably hard to see, but on average, just make this full screen. The operators within the Midland had averaged about 2,000 pounds per foot for the most part. And what you can notice is there's been some variation around there. So you have some buckets of 1,800 pounds per foot, you have buckets of 2,300 pounds per foot, some beyond that 2,500 pounds per foot, so going pretty intense. But on average, they're right around that 2,000 pounds per foot across all these zones. Now, something that's interesting is QEP is actually quite a bit lower. So they're around 1,500 pounds per foot. You can also see Enverus down there, ExxonMobil's down there as well, but they're pretty far down there in terms of proppant intensity. So that could be the first reason why they're underperforming. Now this chart's interesting. So this is looking at fluid intensity on the y-axis, so that barrels per foot metric now. And again, we have checkers on the x-axis. Now what's interesting here is you can see a lot of the operators are pretty much in that 50 barrels per foot mark. There's some variation around that, but for the most part, they're averaging about 50 barrels per foot. Now what's interesting is you can see QEP way down here at about 30 barrels per foot. So they are by far the lowest in terms of fluid intensity out of all their peers within the play. So that's probably the leading cause of why they're completing their wells the least optimally based on our modeling. So definitely we've highlighted proppant intensity being low and fluid intensity being very low in respect to their peers. And in respect to the optimal design, which is that 2,500 pounds per foot and 74 barrels per foot on average. Now this is just looking at another metric. So this is looking at lateral length. So you can see there's buckets in that 1 mile lateral, the 1.5 mile lateral, the 2 mile lateral. But for the most part, a bulk of these operators, their average is about that 2 mile lateral. So call it north of 9,000 feet. You can see QEPs right around there as well. So they're not lagging in terms of lateral length at all. Pretty much in line with peers. Now what we're looking at here on the y-axis is closest horizontal distance at drill times within a 100-foot vertical. So basically what that is saying is we're looking at wells that are spaced 100 foot vertically apart, so call it within the same bench. How far are they apart horizontally from their nearest neighbor? And you can pretty much see that there's some variation around the mean, but the mean's pretty much at that 6 wells per section, so 880 feet. And you can see QEPs right around there as well. There's some operators that are slightly tighter, nothing too crazy though. Pretty much the average is that 6 wells per section or that 880 feet. So we'll keep that in mind when we go to do the inventory analysis as well. Now this is just looking at another potential thing that'd be causing QEP to underperform. This is looking at closest vertical distance at drill time outside 100 feet. Now the way to think about this metric in simple terms is how close are they spacing those distinct benches apart, call it maybe within the Wolfcamp A, for example. If they're drilling 2 benches in the Wolfcamp A, how close are they to each other? Or if they're drilling between different zones, how close are they together? So you can see for the most part, operators are spacing those zones on average, call it north of 300 feet, north of 350 feet even. But once you look at QEP, they're sub 300 feet, so about 280 feet. So they're definitely the tightest in terms of how they're spacing their their benches within the Midland here. All right, so we've basically identified pretty much the leading cause of why QEP is underperforming, and it's pretty much a completion story. They're largely underperforming in terms of fluid intensity and proppant intensity. I shouldn't say underperforming, they're largely undercompleting compared to their peers and what we consider optimal. So what we can do is go back to the main dashboard and start honing in on QEP and maybe looking at how they're performing through time to see what we can tease out. So the cool thing about these row charts here is they're all interactive. And for example, I have QEP here. So I can just click on QEP. And basically what that's going to do, it's going to automatically update all the charts we have within the platform. So you can see this chart updated. Basically every single chart that we're looking at within the platform and all the different tabs is updated as I click and filter through these row charts. So I clicked on QEP. So we're just looking at QEP wells. And then what I'm going to do is I'm just going to select their 4 most active intervals, and that's just to simplify the analysis as we go through this here. So now we selected 193 wells, or 226 wells here, sorry, once that loaded. So now we can just take a look at QEP, maybe see what their position looks like here and how they're drilling their wells. So it's a little easier to see now that we've filtered down. So we have the lower Sprayberry here in yellow, the Wolfcamp A here in a lighter yellow, and then we have the Wolfcamp B upper in blue, and middle Sprayberry in orange here. So you can see that they're actually drilling their wells pretty tight across those benches as well. So they're pretty much all fully bounded wells, which is interesting. So we can just look at that there. All right, so now let's dive into how QEP has been performing through time. So we're going to click on this through time analysis tab here. I can get rid of this because we don't need to highlight QEP anymore. Now we're looking at the exact same row charts that we were looking at in the completion and spacing analysis, looking at which scenario maximized oil EUR and which scenario maximized MPV. Now what's interesting, once we hone in on just the QEP wells, you can see that still that 2,574 case is pretty high up there, but it's actually been passed by this 2,550 case in terms of what maximized oil EUR. So a little lighter completion in terms of that fluid intensity. Now, without getting way into it, that could probably lead to, or that could probably be explained by where QEP is within the play, a little further north, not quite in the core of the core. So the rock might not respond to this bigger completion design versus this slightly smaller completion design where the MPV is maximized. All right, so let's get into some of these charts here. So let's make this full screen. Now, throughout going through this tab, the through time analysis tab, again, we're keeping all these charts consistently colored, looking at RS interval as the points are colored by. And then what we're looking at here is lateral normalized oil EUR per 1,000 feet. So we're just looking at their performance through time, 2016 to 2019. Now, what's interesting, I'll just keep this legend open here. 2016, they were averaging about 60 barrels per foot in terms of oil EUR, which isn't bad. But you can see in the last 3 years, they're pretty much averaging 40 barrels per foot, and actually in the 2019 performing quite poorly. And you can see it's also a mix of the zones that they've been drilling as well. So they've gone from drilling pretty much only lower Sprayberry and middle Sprayberry, very little middle Sprayberry, mostly that lower, and then they've started to mix in these Wolfcamp zones over the last 3 years, and their EUR has come down, and so has their lower Sprayberry EURs as well. So it could be pointing to that vertical spacing that we were looking at, how they were the tightest in spacing their benches. That could explain this. Now this is looking at the same thing that we've been looking at in the previous charts, percent of max oil EUR captured on the y-axis, and then we're just looking at it by vintage just for QEP here. So 2016, 2017, 2018, right around that 60% that we saw, they've actually increased it to about 74% of optimal in terms of that oil EUR in 2019, but still nowhere near their peers, especially on average over these 4 years. So we can look at maybe why they're improving in 2019 as well as we go through this. So this is looking at proppant intensity on the y-axis and then by vintage. Again, we have everything colored by RS interval. So you can basically see they've completed their Strawberry zones at about 1,500 or 1,400 pounds per foot pretty consistently over the last 4 years. They haven't really deviated from that. And then they've been completing their Wolfcamp zones at around 1,700, 1,800 pounds per foot over the last 3 years as they've mixed those zones in. So you can see they've really been leaning towards drilling more Wolfcamp zones in the later years versus the Strawberry zones, especially in 2019, which could lead to why they're perhaps doing a little better in 2019 than we saw in the previous years, mixing in those Wolfcamp zones and mixing in a little bit higher completion intensity than they're doing in the Strawberry zones. Now, fluid intensity is pretty much the same story. Lower intensity in those Sprayberry zones, around 30 barrels per foot, and then a little higher in the Wolfcamp zones at around 35, 36 barrels per foot, but it's actually come down a little. Call it closer to 33 in 2019 for those Wolfcamp zones. Still nowhere near what we consider optimal at that 2,550. And so that's why you can see they're probably pretty far off their optimal due to that. This is just looking at spacing through time. So looking at that, again, closest horizontal distance for that same zone spacing or same bench spacing. Pretty consistent through the years, not much variation through there. There's some noise around the mean, but pretty much on average 6 wells per section over that 4-year time period. So not much to glean from there. We basically have already identified that it's pretty much a completion story in that sense. Now, this is just a cool chart that you can spin up using the completion sensitizer. So what's cool is since we have every single one of these wells, what if scenario completed at whatever completion design, what I've done is I put the 2,500 pounds per foot, 50 barrels per foot EUR, predicted EUR, per 1,000 foot on the y-axis, and then on the x-axis, we're looking at that same zone spacing or that same bench spacing. So this is trying to tease out if there's any degradation moving to tighter spacing through these different buckets here. We don't really see it in this well set that we're looking at, but for the most part, there's very, very skinny well set towards that tighter spacing, and then these bigger spacing buckets, pretty mixed bag in terms of going greater than 1,000 foot spacing. We don't see much uptick in performance. And that's pretty much been highlighted in the charts that we were looking at for all the operators. Everyone's pretty much doing that. That's 6 wells per section. All right, so now that we've identified QEP as an underperformer, it's a completion story. Now we can look at what their optimal PUD value could be. So I'm just going to open this production data tab here. Now getting into here, this is where we can start pulling out type curves, single well models, and development models, all that sorts. So looking over here, we have the RS type curves on. We're lateral normalizing these type curves as we look at them. And then what I've done is I've just turned on this RS ML prediction scenarios. And what that's going to do is it's going to spin up the curves for these completion designs that I've selected here. Now, just for the sake of looking at everything in a clean format, not getting too much noise, I've left on just these 2 completion designs of interest. Basically, that 2,500 pounds per foot and 74 barrels per foot that we identified as the top completion design in terms of maximizing MPV for the whole play. And then we've got this 2,550 on that was maximizing for the QEP wells that we're honed in on. So just looking at this chart really quick, we're looking at a rate cum plot of oil. And so this red line here represents all wells. So that's the actual wells and how they're performing. What this orange line represents is how these, or when we take these wells and run them through our completion sensitizer, not changing anything, so using the same completion design, what do we predict these wells should do? So what's interesting is you can see QEP's actual wells actually fall off quite a bit steeper towards the tail end of their production life there. And you can see the prediction we have is a bit flatter. So basically what this tells me is that QEP's declines are steeper than what we see or observe on the average for the whole play. So that's why you can see they steepen there versus what we're predicting is a little more of a smoother profile. Now, the cool part that we're looking at here is the optimizing case. So if we were to take all these wells and run them at 2,550, which is what was optimal for QEP in terms of maximizing MPV, you can see this curve here. So right now, we haven't really filtered for anything. We're just looking at all QEP wells 2016 forward. But since we're running every single one of these wells at the exact same completion design, you don't really need to do any additional filtering. If we want to pull out a what if type curve at this completion design, we can just do that. Now, one thing to note, we're looking at all the zones right now. So typically the workflow you do in the Midland is you want to look at type curves by interval. So for example, we can just go back to here, select the lower Sprayberry, go into the production data, and then we'll just be looking at the Lower Spraberry and the QEP curve for that. And once that's done, you can basically hit this download single wall model here. And what that'll do is it'll download the single wall models here. So you can see I've already gone ahead and downloaded those 4 single wall models for those 4 zones that we've been looking at, just in the interest of time. So they're pre-downloaded there. Now, the part that we need to look at optimal MPV value is get a development model. So basically, to look at a development model, we want to look at what are they going to be doing now if they don't move to an optimized design, so we have something to benchmark against. So I'm just going to group their wells by RS interval. And again, I've already downloaded this ahead of time in the interest of time. But what you can do is select there. I've sorted the curves by RS interval. And then what you can do is click on this development model here and download the development model. Again, I have this pre-downloaded here. And so that's the development model for all the zones. And what I did is I just filtered to 2018, 2019 wells on a go-forward basis. So I'm going to jump into the development model now, and we'll quickly step through that. So this is what the development model looks like when you open it. It's basically an Excel file sheet, and it has all the curves that I've compiled in here. So basically the go forward as is scenarios are these first 4 curves that we have here. So that's what I was talking about when I selected just QEP's 2018 and 2019 wells by interval and just downloaded the type curves there. So basically assuming what they're doing now is what they're going to be maintaining to do to develop the rest of their locations. And then what I've done is I pulled in those optimal curves that we pulled out as well. So looking at all those same zones, but run at a 2550 completion design. So these are those 4 curves there. Now I won't dive into everything that we have in here. There's quite a bit, and we could probably spend an hour just going through this model, but we'll go through the important bits. So essentially, when you're looking at all these cells, you'll have blue values and you'll have black values. All the blue values are manual inputs that we can change and just recalculate the sheet, and it'll update everything. Okay, so here are some of the key metrics in terms of type curve. So this is just looking at oil EUR. So the original oil EUR of these 2018, 2019 wells versus what they would have been if they did this optimal completion design. So you can see most of them have a pretty big step up in terms of that completion design. And most notably in the Lower Spraberry, they can see a pretty big uptick from moving to this more modern completion design, or this bigger completion design, I should say. Now, this is the same thing, but looking at it in terms of MPV, and it's the same story. You can see MPVs go from basically 1 million to 6 million, all the way up to 3.5 million to almost 9 million. So a pretty big uptick in terms of MPV there. And that's just at an MPV at a per well basis. Now, something to touch on too, as you change completion designs, you're going to be changing your well cost. So that's what we're looking at here. So this total D&C cost here. So these are the total D&C costs of the wells, assuming that completion design that they would use on a 2018, 2019 basis. So right around that 1,500 pounds per foot that we saw. And this is what it would be if they moved to that bigger completion design, that 2,500 pounds per foot and 50 barrels per foot. So you can see it goes from, call it 6.5 million on average, all the way up to close to 8 million. But they do receive that big uptick in EUR performance as a result of that. But the well costs do increase as you move to that bigger completion design. Now, I've kept all the other economics apples to apples, just for the sake of comparison. These are all the economic assumptions, processing assumptions. Now, this is the meat of it. So if we're calculating PUD value, we need inventory analysis. So that's where these numbers come in here. So net remaining locations. So I'm going to quickly go into how we got these numbers. So I'm going to go back into Prism, and I have this inventory analysis tab. So within Prism, we have an undeveloped land module. And essentially what that is it takes all the operator shape files that we have for their land within the platform, and it does inventory analysis on all of that land. And essentially once we have that, we can spin it up by whatever metrics we want. So I'm quickly going to go into the filtering for the undeveloped land. So when we are looking at the spacing analysis, back in the completions and spacing analysis tab, we basically saw that every operator is doing 6 wells per section, so 880 foot spacing. So that's what I've gone ahead and selected. That's how the inventory is going to be calculated. So that's going to be assuming the spacing historically and the spacing on a go-forward basis for calculating that inventory. So now you can see I've quickly just rolled up the net remaining locations. This is assuming a 2-mile lateral, so what the average has been on the play. And you can see QEP essentially has 688 locations remaining. Now what I've done is just split up that data by some different metrics. So essentially what we need is these net remaining locations by 10,000 foot lateral, and this is just by RS interval. So how we have our type curve split up. So I've gone ahead, I've taken these numbers out of this chart, and that's what I've plugged into the net remaining locations here in this line here. And so this is what's going to drive how many locations they have remaining to drill. And for the sake of simplicity, we have our rig cadence down here. Basically, what I've done is I've assumed a drilling schedule over a 10-year period. So a flat development over a 10-year period. So you can see that calculation here. So assuming they develop each one of these areas just consistently over that 10-year period. So you can see that there. All right. So now just to get into the PUD value. So we had the individual well MPVs. Now what we're looking at here is the development model summary. So this is going to be the developed MPV. And so since we're assuming that flat 10-year development for all these curves, we're looking at all of them on an apples to apples basis. Now what we can do is look at what is the PUD value assuming just a 2018, 2019 curve as is going forward. Basically, we get a value of 1.2 billion. So that's just going to be the summation of these 4 original type curves. Now, if QEP were to move to an optimal design, we would see that value essentially double, so 2.4 billion. So moving every single one of these curves and completing them at 2,500 pounds per foot, 50 barrels per foot, they could essentially double their PUD value, going from 1.2 bill to 2.4 bill. Now, this is assuming a 55 and 3 price deck. What we can do is just flip it to maybe a more representative price deck of today's pricing. So for the sake of experimentation, we'll change that to $40 WTI and $2 Henry Hub. We can just recalculate that, and then we can go see what the PUD values would be there. So now you can see if they were to assume this 2018, 2019 case going forward, they're essentially destroying value or not making any money, losing 50 mil over that time period. Whereas if they were to move to this optimal completion design that we've identified, they could add about 700 million value. So basically in today's pricing environment, it goes from basically a no drill to a drill decision, which is pretty interesting, just from moving to a more optimal completion design. So yeah, that's my presentation. Thanks, everyone. And so we'll get into Q&A now.
Great. Thank you, Nick. So we have a couple of questions that have come in, and I'm just going to go through them. We could have missed it, but how are you determining EUR? Why did you choose maximizing EUR as your criteria for optimal?
So we did look at, maybe I'll just jump back into the platform here too, which would be good. So we did look at what maximizes oil EUR, but we actually used the completion design that maximized MPV for looking at the case of QEP wells. So that 2,550 case, that's what actually we considered optimal for maximizing MPV. It wasn't the oil EUR. If that makes sense.
Great, thanks. And then the next one here is, how do you account for the potential for increased interstage interference leading to steeper declines when running increasing completion intensity scenarios?
Increased interstage interference. So that's a good question. So that kind of goes into the methodology of what we do when we do the completion sensitizer. Without getting too far into it, essentially what we do is we input individual monthly values into the completion sensitizer. And then when we go to predict on the output, we predict individual monthly values up to the first 36 months of a well. And so we'll predict, call it at whatever completion design, month 1, month 2, month 3, all the way to month 36. And then what we'll do is fit autocurve to that. So what that tries to capture is that change in type curve shape as we move to different completion designs, which you can see here. So these are the curves by different completion designs. So you can see how the curve shape changes, or the production profile shape changes as we move completion designs there. So that's how we try to capture that.
Great, thank you. I have another one here, which is how are the net remaining locations calculated?
Net remaining locations. All right, so go into inventory analysis here. Just going to select one interval so we can see it. Essentially what we're doing is it is basically area math. So what you think about in a historical nav workflow, for example, basically taking the operator shapefile that we have, looking at the existing wells on that piece of land. So just let this load in here. So this was the operator land shape red. So that's the operator land in red. And you can see these areas here where there was actually wells drilled. They're just not loaded into this tab yet, but you can see that we've drained the wells there. So essentially we're taking all the existing wells using the spacing zone that or the spacing scenario that we've selected and draining all the acreage. And basically what's left in terms of red area is going to be what we use to determine the locations on a go forward basis. So that's how we're calculating the net remaining inventory. And then we have this for every operator. So it's very scalable and quick to do within the platform.
Great, thank you. And just as a reminder to everyone who's on the call, if you'd like to ask a question, please just use the Q&A button on the bottom of your screen, and you can submit it here, and we can have Nik answer it. And I have one other one here, which is what is the time period what time period do you run your type curves and economics over? I think that.
Gotcha. Yeah. So everything we're assuming for our type curves and our economics, we use a 30-year time period, so 360 months. So if you notice when I was going through some of these earlier charts here on the y-axis, it said EUR 360. So that's going to be looking at a 30-year type curve for basically everything that we're looking at. So it's all on an apples to apples basis, looking at a 30-year forecast.